welcome to the RedMars Podcast. I'm your host, AstroJake, and today we're doing our very first video podcast. Now, for those that tune in audio only, we will still be providing a audio podcast that you are listening to as well. You just will not have the video portion of that, but I will describe what we're looking at for those that are listening. They still get the kind of idea of what we're talking about and going into. So with that, for today's topic, we're diving into something that is very fascinating, and for people like myself who are fans of sci-fi, this is going to be a very fun topic. So from technologies from the Cold War sci-fi to modern moon day landers, we're going to be getting into the sci-fi space vehicles of past, present, and future, and really go into what some of these ideas of the past were and how those are driving future and modern day spacecraft. And some of these, may have been back in the Jetson times or even before that we thought were completely out of this world. But today we're looking at bringing these technologies back to life through programs such as like NERVA, which is a nuclear propulsion technology that NASA is currently looking at. We also have things that we can talk about, such as Orion. This was an earlier project that talked about kind of like a pulse jet, but using nuclear technology as well. And then we go into, I guess, the earlier days of what the Dream Chaser now looks to become. And not sure if Sierra Space kind of went off these designs, but we'll kind of dive into that and give a visual representation for those that are watching and kind of talk through it for those audio listeners. So without further ado, let's get right into it. So for those that are watching here on YouTube, I do have a screen share set up so we can go through. We're pretty much just going through online some resources that exist so we can see, whether that be Wikipedia, YouTube, whatnot. We're going to dive in and kind of just talk through kind of the things that we see here today. So let's start back in the Wild Wild West, the early days of when funding wasn't as much of an issue and people were really allowed to explore the sci-fi ideas that came post-World War II. Now, many technologies came out of World War II, and scientists such as like Wernher von Braun were really key to the development of, say, the V-2 rocket and later to become space exploration during the space race with Russia. With that being said, many other projects actually took place during this time frame post-World War II. And the first one we're going to talk about is the Orion project. Not the modern-day Orion that you probably hear about, but something more along the lines of a nuclear pulse jet, pulse rocket style technology. So the first video I have up to show is just a few seconds of what this nuclear Orion prototype kind of looked like and really give a visual to that. So again, timeline, this is back in 1959, so we're a little bit outside of the World War II era, but we are pre-Apollo. So this was kind of a predecessor, I guess, or an idea before we came up with the Atlas V and all that Wernher von Braun was really part of. So let me play this here and show those who are watching what we got. So what we see here is it looks like a pylon, really, that is launched from the Earth and with pulses of explosions propelling that object into the sky. It doesn't make it too high. This is just the prototype to show that this pulse technology is capable of propelling an object from the surface into the air, and then it just releases a parachute and glides back to the ground. Now, this is super cool technology, and there are countries today that are looking into this for, I guess, a next generation of rocket system, which is super exciting because we've been looking at these liquid-fueled rockets or solid rocket booster propelled devices or systems, I guess, these rocket systems that really haven't come too far from back in the Apollo days and even before that, the Mercury project. And for someone like me who loves sci-fi, I love seeing new technologies really get put out there and pushed to the limit. So something like this where a pulse jet, pulse rocket technology, especially ones with nuclear propulsion, is coming back into light. It's super exciting. So one of the countries that have come out and said that they've successfully tested this is China. Now, there hasn't been much proof behind this. There has been some circulated videos that are maybe questionable, but it's a very cool technology nonetheless. And in the space industry, when it comes to human exploration of, our solar system and beyond, we're really all allies in this effort, regardless of geopolitics that's taking place. And we all just want to see the technologies kind of progress and really get us to that next level. So whether it's China, Russia, the United States, Canada, Europe, whoever, JAXA, that is working on these technologies, we all want to see them succeed. Now, obviously, take a step back, and from a defense standpoint, we always want to be the ones who are ahead, and every country obviously does. But for space exploration, I just want to say, like, we're all on the same side. The more companies that are able to succeed and progress with these technologies, we all become successful in that sense, because we can all kind of learn from each other and go from there. That's why you see all these other countries come together on the International Space Station. So that is Orion. So I have some notes here that we can kind of talk about the details. So Project Orion was a nuclear bomb propulsion. Pretty much expect a miniature nuclear bomb exploding at each pulse to get you up to a given delta V. This was developed again in the 1950s. Orion was one of the most ambitious space projects ever proposed. The idea was using controlled nuclear explosions to propel a spacecraft forward. Scientists did believe that Orion could carry thousands of tons, which would be enough mass to go and build a space station in orbit, possibly in a single launch. Because those explosions are so powerful, you actually have a ridiculous amount of thrust or explosive force to move that mass into space. And so with that, it would be less trips to space than what we have today with a regular liquid-fueled rocket or solid rocket booster-propelled rocket, and it just gets us there sooner. Now, cost for this technology and the dangers that come along with nuclear detonation, obviously, has been the reasons why this didn't go anywhere in the first place. So that brings us to, why was it abandoned? Well, there was a partial test ban treaty which banned nuclear explosions in space. That treaty, I believe, recently has been repelled or pulled back, and there's kind of some iffy area. Gray zone was what's going on in the geopolitical world right now, but nonetheless, this whole technology of nuclear propulsion is coming back to light. So the worry was nuclear fallout raining down back on Earth from orbit, and obviously that would still be a worry, but nuclear done the right way can actually be very safe. You know, we don't want anything falling back on us, let alone radioactive material, but we'll see where things go. There are measures that can be taken to make it a safer measure or safer technology for the exploration of space. All right, moving on. Lunex. Lunex was a USAF mission proposed to bring humans to the moon. And this was a, contender to the Apollo program when they were looking at how are we actually going to go to the moon during the space race between Russia and the United States. Well, many don't know that there was other proposed missions outside of the Apollo program, and the Lunex project was one of those. Now, the Lunex project, again, very sci-fi-ish, cool technology. This came back in, 1958. And this lunar mission kind of brings us to the whole Sierra Nevada Dream Chaser style spacecraft again. And I got some images here. There wasn't a whole lot I could find on the specifics of kind of the timeline of things and whatnot, outside the fact that their proposed mission was to land on the moon in 1967. But here's the images. For those that are unable to see, think of kind of like the X-37B style space plane or the Dream Chaser, and then sit that on top of a kind of triangular looking propulsion unit. There's other designs that I have up here that you can see that kind of look like a cross between a capsule with some fins on it, but more or less you had the space plane with another stage that was the main propulsion unit attached to the bottom of it. Interesting looking. Unfortunately didn't go anywhere. I think this would have been a very cool contender to the Apollo program if this would have taken off. Now, I think the problem on this one was kind of cost and timeline and whatnot, and with the proven technology of capsules and that, I think that's another reason why the Apollo program was seen as a better fit. And I think just kind of do what you know rather than picking these sci-fi technologies. This is a repeated thing over and over and over again. You'll see with these sci-fi style technologies or fringe science ideas. People like Nikola Tesla, Wernher von Braun, Albert Einstein, all these guys have come up with crazy, I won't say crazy, I won't make borderline crazy, but some pretty cool technologies or theories of technologies that could be built and would have put us so much farther ahead of our time today. Think of having a permanent lunar base back in, the late 1960s, early 70s. We're trying to do that now, and we're still years away from it, and we're in the 2020s. So Artemis missions do look to do that, but we're just quite not there yet. So to go back to, history repeating itself, We had this back in the late 50s, early 60s in Canada. They had the Avro Arrow, which was a jet before its time, being able to go Mach speeds, and it was really a flawless jet. But unfortunately, it was canceled due to funding costs, and they didn't see the cost or the what is in it for me kind of thing, where it's like, what do we get in return for building this jet? They didn't see enough money coming back in from the project, which ultimately led to the cancellation of the Avro Arrow. Now, what happens to those engineers and scientists that created the Avro Arrow? Well, they go elsewhere. They go where they can get funding. And many people swooped in and grabbed these individuals. These scientists went to places like NASA. They also went to Europe, where they went and created the Concorde. So where the money is and funding is able to be flown, then you'll find the scientists that are willing to do the work. There's plenty of them out there with these very cool and sophisticated fringe sci-fi proposals of technologies. All you got to do is look and you'll find them. They're everywhere out there. Some of them viable, some of them not so much, maybe just not yet. Maybe you just got to get more creative. But those technologies exist and people are out there with them. Avro also had the Avro car, which looked like a flying saucer, another technology that was pretty cool. There's also scientists that experiment with high voltage to make flying discs become a thing, and they've proven that they could do this. They were able to float objects with high voltage. There's many cases of different scientists and, even amateur scientists experimenting with these types of things and making it happen. Now, with things like YouTube and that, it's becoming more apparent and people are sharing these technologies online, and social media has really made that a lot easier to kind of flow those ideas. Now, with that and technology, you get things like AI that has now come so far, and it makes it super hard to tell what is real and what is not. So what is reality versus an AI generated film, or even, different tricks you can do on a camera to make it look like something's happening when it's not. So these illusions and that. So kind of getting sidetracked here, but moral of the story is a lot of these sci-fi, if not all these sci-fi style technologies that were really proven at their time, that were not chosen just due to not viable in terms of cost versus return or whatnot. Cost analysis usually crushes these things, and they don't think they're going to make their money back, so they say too bad, and away it goes. Now, who knows what these could have been? There's a lot of guesstimates of what could have happened if these technologies had succeeded, but I'm happy to see that some of these are coming back. So better late than never. Very curious to see where these things end up, but that is the Lunix project in a nutshell. So next up, NERVA. So this is a nuclear rocket program, and I'll pull this one up here for those folks who are watching. And this is on Glenn Research Center, so anybody can go online and search up the Glenn Research Center, look up NERVA, and just find the link to NASA. You'll be able to read through what they're actually talking about. Here they have a picture of a prototype of the nuclear rocket engine, and NERVA stands for Nuclear Engine for Rocket Vehicle Applications. This was a joint NASA and Atomic Energy Commission endeavor to develop a nuclear-powered rocket for both long-range missions to Mars and as a possible upper stage for the Apollo program. Well, the Apollo program has passed, but we are back in action going to the moon, and that is Artemis. Now, I don't know of any nuclear propulsion proposals for the Artemis missions, but I do know that they are back looking at nuclear rockets for going beyond the moon into solar system, looking at multi-generational travelers to put on these systems to send them to, like Century, different solar systems, different galaxies that are within several light years away. So you can really make it a few generations and get there. And there are other technologies I've talked about in my podcast, such as solar cells, where they think they might be able to get people there within a single generation, a family, to the destination at hand. So it's super cool. Very curious to see where this goes. But yeah, so just reading through, I'll read through the first little bit here just for folks on audio here can get a better understanding of what this was. So it's called Project Rover and NERVA. There are two programs here. So after World War II, engineers became interested in utilizing the massive power of atomic fission for aircraft and missile propulsion. Again, here we go back with the defense thing. So in 1945, the military began sponsoring efforts to develop an atomic aircraft. Engineers, however, could not overcome issues involving the required shielding for crew or the fear of radiation at crash sites. 1955, the military partnered with the Atomic Energy Commission, AEC, to develop reactors for nuclear rockets under Project Rover. The nuclear rocket would be an upper stage, not fired until it had entered space. So that way we remove the risk of a crash site or not the risk, but of something going wrong during the detonation of the engine inside the atmosphere that would then rain back down on the population. So the idea here was if you blew up in space, there's the possibility that you could keep it outside of our atmosphere, put it in like graveyard orbit, who knows. But the idea was that this was a safer alternative to launching this thing or igniting that explosion or that reaction in the atmosphere of Earth. So this would also reduce the contamination possibility of Earth. So the nuclear rocket would use fission to heat liquid hydrogen and expel it as at thrust at rates that would supersede those of chemical rockets. That is why this is such a attractive option compared to liquid rockets, is the sheer force, explosive force that comes from an atomic reaction. Now, fission is a dangerous one. Fusion would be better, but we're not quite there. So I won't read through the full thing, but I definitely encourage those who are interested in this to come in and really get an idea of what a nuclear rocket looks like. For those that are listening online through the podcast, definitely go and take a look when you have a chance at NERVA or Project Rover, and it's super interesting. We could do a whole episode just on Project Rover, which might be an interesting one to go and talk about that and how it played a role at Los Alamos as well. But yeah, so some key details about this one. So this was a nuclear engine for rocket vehicle application. It was tested and proven to work. So it has been proven technology, just not used. So this engine could have cut Mars travel time in half, but political and budget concerns ended it. History repeats. Today, NASA is revving up nuclear thermal propulsion for future deep space missions. Yes, so it's using the reaction to heat up a fluid, and that fluid is then expelled. And that is our rover NERVA program as it is today. So next up is the Boeing X-20 Dyna-Soar. Dyna, D-Y-N-A, soar as in soaring airplane. I like the play on there. Lots of fun. So for those watching, I brought up the Wikipedia just to show you kind of some interesting images of what it looks like. And if it looks familiar to those who have never heard from this before, that is because it is very closely designed or resembling. I won't say it was designed because obviously this was in the past, but Virgin Galactic's Starship, not Starship. I'm getting these all confused now. SpaceX has the Starships. Virgin Galactic's spacecraft that they fly with the pivoting kind of rear wing that they have there that allows them to do that flip maneuver. It looks like that. This one doesn't have the pivot, but it looks like a fixed version of Virgin Galactic's spacecraft. So very cool. I'm not sure if that's where they got it from or not stole, but kind of copied a little bit of that legacy design. This one was a bit interesting because it had a stage that would separate from it and leave you with just the space plane. So it's kind of like the Lunex spacecraft, but split in two. So you can have a separate stage where it was all connected on the Lunex one. But I do have a video here. This is way back from 1962. So sorry about the quality. And I'm not sure if the audio will come through, but at least we can get some visuals here. This is those very cool, if anybody was ever in the military that's listening to this, you have some really old training videos, and it looks just like that. So here we have an image of the rocket on the top of a propulsion device.
Glider will make a flight around the world.
Yeah, so they're talking about a piloted glider. So you have that propulsion unit that sends this up into space, and then from there it operates as a spacecraft, and then it'll glide back. Now, I can fast forward through just a little bit to show some of the designs here. Let me see if we can find. There's the uncovering.
And this is a model of the glider our Air Force test pilots will be flying.
So yeah, there's a model of it. Again, this was an Air Force effort, so Air Force pilots would be the ones that would get to do this. Today would be under Space Force, which is pretty cool. And I hope some of this comes back, if not is already underway with the X-37B and so on. I know these are unmanned, but it'd be really neat to see a manned version of this, or a human version of this, or human flight rated design of this. Let's see if I have any other parts of this video that is worth watching. I think it kind of goes more into some of their other test X aircraft. Boeing typically goes with that X prefix. And here's another
for flights down the Atlantic missile range.
Visual representation of what it looks like. some cool concept art here as well that if you're interested, definitely worth looking at. A lot of this, I feel, fed some of the design efforts for the shuttle missions, which, again, canceled. But they at least made it and flew for quite some time. Obviously ended in some tragic accidents, but that being said, was still a great feat, engineering feat for us. However, it was super expensive. So we can kind of talk about that in a moment. So the next part I wanted to talk about was kind of like what came after Apollo. So we talked about this was pre-Apollo. Apollo missions ended up winning. We ended up with the Saturn V. But then what comes after that? So the Apollo engineering that came along with that gave us a lot of wins. So we did end up with, what remains today is the most powerful rocket ever built. That is the Saturn V. Now, we do have many contenders today that coming close, especially in size and actual thrust. So we do have New Glenn from Blue Origin that is just sheerly massive and has a ridiculously sized payload fairing. And then you have Starship and its massive first stage. They were talking about sending 100 people at a time into space and over to the moon. I believe that's going to be part of Artemis 3 if they can get through their little issues that they're having of fireworks shows over the Caribbean. So, if we can get past that, then and we will. It's just a matter of time. With any type of technology that you really push the limits to, you can expect that things like this are going to happen. So you have to get through this, really push the limits, and then once you work out the kinks in that, then you have the ability to get something human-rated and then becomes a viable spacecraft. So it's all part of the development process. Just SpaceX is a lot more public with it, and it's how they kind of get funding in that as well. So props to them for really being out there in the public doing what they do and showing everybody the technologies and how hard they're really pushing the limits of what we know. But yeah, with that, we came out with, like I mentioned, the Saturn V rocket. We have the lunar module, which was an amazing engineering feat. It's paper-thin exterior, yet still protected the astronauts from the harsh radiation and space environment. And then we have the Apollo guidance computer, which we could do an entire thing on. I think I've mentioned it on Space Computer, on one of my Space Computer episodes. So definitely go back and take a listen to that if you want to hear about, the sheer engineering feat from that one and how a computer that really has just as much compute power as a modern day calculator, if not less, was able to fly the Apollo mission. So that's super, super cool. So what comes next? Well, NASA originally planned Apollo missions up to Apollo 20. But as we keep talking about, there were budget cuts in funding and not return on investment. And that ended up to some political interests changing, which is why we didn't get through Apollo 18, 19, and 20. Unless you watch Apollo 18 movie, maybe it did exist and aliens were the result of why we never heard about it. We don't know that. But yeah, if they did succeed with these Apollo missions and funding stayed, the plan was to build a permanent lunar base through the Apollo missions, which would have led to a sustainable base on the moon by 1980. Now, could you imagine if we were where we are trying to get to today in the 1980s? That would have been absolutely ridiculous. 40 years later, here we are trying to get back to the moon and build ourselves a sustainable presence on the moon. If we had 40 years from when we were already there, people would be living there as if it was their regular day job, living and going to and from space, and maybe we'd already be deep into the solar system. I definitely think that some of these sci-fi-ish movies that talk about, hey, what if, are very cool ways to think about what could have been. But without dwelling on the past, looking at where we are today, we got to make sure we don't repeat the history or repeat our mistakes from the past and continue to push forward and make sure that 40 years from now we can say, hey, aren't we glad that we kept going, moving forward, and put that moon on that base on the moon. So we'll see where things come. So I mentioned the space shuttle era. So there were some failures with that. There was cost issues. $1.5 billion per launch, which brings me to the SLS. Now, the SLS wasn't originally part of this conversation, but talking about money just makes me really think about it. We're in the billions of dollars per launch. Then you look at private industry companies like, ULA, Virgin Galactic, Boeing, Northrop Grumman, Blue Origin. All these guys are putting things into space at much lesser costs, specifically SpaceX being a orbital launch vehicle with their Falcon 9 and Falcon Heavy. We're talking, under $100 million to do that launch. And if you scrub, well, we're less than that. It depends on prop load and that and how much time was left in that prop load, or if you did a full prop load or whatnot, and then you have to offload it off gassing, so their cost comes with that. But when you're talking about the SLS, you're still in the hundreds to $billion range for a scrub launch, and that's taxpayer dollars. That's a lot of money. And when we have these launch providers that are doing it at a much lower cost, why wouldn't we use them if the capability is the same? So understanding that SLS is, an engineering, I won't say masterpiece because it's using older technology, but it's huge. It's a big rocket. It shows USA, which is, it's fascinating, and it's fun to watch, and just the sheer rumble, if anybody's got to see the first SLS launch, it's incredible to see, and the sound and roar of this thing is wild. But is it worth it? And that's where it kind of comes down to. So this is one of those budget cuts and cost analysis, political view change that I think this is justifiable. Let's get rid of it. But we have alternatives that continue to push us forward. And that's where I think the difference is from the past. So I'm glad that they're making these calls, but I think we got to keep making sure that if we do cancel something, well, what's the alternative, and make sure we have a backup plan to keep going. So anyways, going back to the space shuttles, they ended up with two accidents, major accidents, such as the Challenger in 1986, and then I think it was 2003 for Columbia, which ultimately was the death of the program. And yeah, it highlighted the design flaws of the spacecraft and really what ultimately led to its cancellation. So with that, we had this huge lull of nothing. Really, we haven't done much since then. We've had the International Space Station, but for the longest time, really, even American and other allied country astronauts couldn't get to our very own space station without the help of the Russians. Now, with geopolitical issues at hand, that led to other issues, and we wanted to pull away from that, which is what SpaceX has helped us do. Now, we had the Soyuz in Russia that would bring up payloads to the space station and that, but really there wasn't much else going on. We are in this consistent experiment research of governments around the world coming together and doing some research on orbit. Now, while that is great and helps us advance technologies here on Earth, and we did advancements with medical, like in the medical industry and all over, it doesn't really help us really push the limits that we could have been pushing without more private industry. So now that we're back into this kind of space race to the moon, you see all these private industry companies coming together now and really pushing the limits, and that is what we need. So it's an exciting time. So what does that mean for us? Well, first one I'm going to mention is Artemis and Orion. Not the old Orion from the late 50s, but a new Orion. And it definitely needs some work, but it's coming along. And it is, again, getting us to that next point of getting closer to being a sustainable habitat on the moon, presence on the moon, with humans living and working there as well. So all these companies coming together are going to make that happen. Artemis is a joint effort from many around, not just the U.S., but many companies contributing around the world on that and different technologies. But mainly the main contenders are here in the U.S., and that being, NASA, SpaceX, and Blue Origin. So super exciting to see that. Orion's like that 2.0 Apollo mission, still capsule-based, which is, again, that proven technology that people don't really like to steer away from. And it's why we still see these liquid rockets as the main propulsion units, because we know it. It's been tested. It's been flown. And the whole certification process for a rocket and rocket engine, especially to be human certified, is so strenuous that it would cost so much money to try and human rate an alternate form. But we need to do it. So that is why, as I mentioned at the beginning of this, looking at these nuclear thermal propulsion and pulse jet nuclear explosion style methods, that I'm very excited to see this happening again. And hopefully we'll get to the point where these become human certified so that we can actually fly them. All right. So fun fact, I guess, about Artemis and Artemis 3. This will be the first landing of the moon of a woman and person of color. So that's super exciting, especially for the whole diversity of space exploration and showing that, it's not just this small niche group of people. It is everybody is a part of this. The whole world as a whole is coming together in this effort of getting us off the planet onto the moon and beyond, and building this sustainable living, working in space, living on the moon, interplanetary species. We all need to come together to do it. So having the representation from Earth in these areas is definitely a needed thing. So very exciting. So what comes next? Well, SpaceX Starship. So it's fully reusable, designed to carry over 100 plus people, as I mentioned. It's meant for the moon, Mars, and beyond. Obviously, they have some work to do, and we don't really have the solution for radiation just yet. And we will talk more about that in other episodes. And now that I have this set up to do a video, podcast style, I can go through and give visuals for what these systems look like and kind of more of the technologies rather than just talking through it. Obviously, I'll still try to talk through it as much as I can for the audio listeners, but a visual representation definitely helps really draw that picture for everyone. So looking forward to talking more about that. And then we talked about the Dream Chaser. Dream Chaser is that space plane that it finally happened. So we've seen all these other ones that we talked about today, like Lunex, the X-40, and all that. And, it led to Virgin Galactic's version, but unfortunately it's still suborbital. So looking for an orbital vehicle that's a space plane, kind of Star Wars-ish, the Dream Chaser is getting us that step closer. And it's that shuttle-like but new and improved technology that should keep us from the tragedies that happened with those systems. So then again, our nuclear propulsion. So with that, I think that the future is a pretty wild place, especially with these technologies coming back into light and countries around the world really pushing the boundaries of what we call physics today and seeing what we can come up with. And with all these new technologies and AI and everything really coming to light these days, we have so much more information at our fingertips that these startup companies are popping up everywhere and really contributing all these little parts. And we need all these companies to come together and really push those limits so those technologies can feed on each other and really help push us. If you have a monopoly of one company doing stuff, you end up with what we had during just the NASA days where you become kind of stagnant and not much progression actually happens outside of what the government is willing to fund. When you have private industry that isn't funded by government or board members and whatnot, and you can have somebody like Elon Musk, Jeff Bezos, and Richard Branson really say, hey, this is what I want to do. I have the money to fund it myself. Let's do it. That's when you get this really creative approaches to problems that maybe we would think would be too sci-fi otherwise. So very exciting to see all this. Really excited to see what the future has in store. Definitely be watching to see where these nuclear technologies end up, as I think that's definitely going to be the future for that. Now, I do think outside of that, if I go on a little tangent for a second here, there are other technologies that I think we could be focusing on that might be a bit more fringe, but they have theorized and been proven otherwise. Things like wormholes and whatnot, or being able to move the fabric of space around you rather than moving through the fabric of space. And those two things are different. If you look at Einstein's theory of relativity, you have somebody on a train moving by and I'm standing on the side. I see them go by. To me, they are moving 120 some kilometers an hour. Just as an example, for them, I'm moving that fast, and it's based on the perception and relative motion. Now, if we look at, say, a UFO, and we're saying, hey, we just saw this UFO move 250,000 kilometers an hour based on it going from this point to this point in a given set of time, and we say, how is that possible? The technology to move that fast is ridiculous, and then the forces that the human body would feel would be, devastating. Well, maybe that's not what is actually happening. It's what we perceive, and relative to us, it looks like that. But perhaps they have space and space and time and the fabric of space moving around them. They have found a way to manipulate the universe in a way that we can't even comprehend. And if that is the case, there would be no physical effects of acceleration on that body or that's whatever they are, as everything else would be moving around them. And now us being the observer, we also wouldn't feel those effects because our person is sitting here. Now, there's a lot more to it, and obviously way off topic from what we were talking about, but just wanted to mention that, there's other technologies or theories out there that I think would be worth looking at. And if we're never looking at them, we're never going to make any progress towards them. So, even if we bite off just a small piece of that and say, hey, we could do this, then that gets us one step closer to getting there. But anyways, without diving too much into it, I appreciate everybody's time. I hope you enjoyed this. If you did, definitely like, subscribe, and follow along. And if you're an audio listener, Let me know what you thought of this with me, giving video but still talking through it, and if you liked it. And for those that are watching this first one, give me suggestions what you think would be better and how I record this. And let's make this a better podcast for everyone. I enjoy doing these, even if nobody ever watched these, I'd still enjoy it because it gives me the time to really dive into some of these subjects and talk about what I enjoy most. So with that, thank you everyone. Don't forget, stay curious, keep looking up, subscribe. I'll talk to you guys later. Have a great weekend.